This is the Skywatcher Flextube 300p Dobsonian telescope, and I've now finally found the time to clean it and put it up there, and as usual a cloud came. So I just adjusted it for terrestrial viewing just to test and align the finder scope. This can be called as the ultimate portable telescope for one person, and anything bigger than this will be extremely heavy, cannot be handled by one person. So the size of the mirror is 200 millimeter, slightly 305 millimeter, 1 foot, and yeah, I'm using this ex-military Eyepiece, which has a lovely, this for tanker thing. I bought it from internet. Very cheap actually. You have to pay for this kind of thing. This, I think the focal length of this is 37 millimeter. So it's really clear, and also you can put your eyes around with this eye cup. It really gives a good view and encloses your eye. And bonus is that you can use this cap. The only thing is that I adapt 2-inch adapter to this. I used one 2-inch adapter for the Hyperion, other Hyperion eyepieces. So really works nice. Astros I showed also exists on this telescope. I will do the first daylight view of this, first light of this, of course I should say, tomorrow in the daylight when it is sunny. At the moment it's cloudy, so we cannot do any. It's getting dark and cloudy. So okay, I'm now cleaning the mirror of this telescope. I've removed it, and as you can see here we have some spider web. So I'm just going to clean this also with a duster before putting the telescope mirror back. This is Skywatcher 300p. That's 1 foot, and I could see NGC 2403 galaxy, magnitude 8 galaxy in the camelopards the other night. Really good, despite all the webcam and the dust and everything. I could do it. Now I marked everything, so I know that the screws. This was the first one I opened, so that's the first screw. The cross one was the second one I opened, so that's the screw. Then I opened this one, which is a circle one, the third, and the fourth, then this and this. So I put them back exactly the way they are. The bottom ones are this and this. So we will see how it will go, and I will show you the result. And this is the mirror. I was worried this is the oxidation. It's not, it's just a little bit dust. So I'm going to clean it now. I have the deionized water and the tap and everything ready. Cotton wool. Okay, I have done the mirror cell here, and I've marked the mirror holders, clamps, and hopefully I will put it back exactly the same place. And I have done it in the past once. You see this label, this sticker, electric tape shows that. And now it is the number 2, and this will be number 3. Hopefully I will put the mirror exactly back on the way that it is, and I will remove it exactly the same way also. So let's do this, and I remove. It's better not to wash it with this whole cell, because there are cork somewhere. It's floating on a cork, so the cork absorbs the water and just gets time to dry or maybe even come off. So it's better to remove the mirror from the mirror cell. And I've done it in the past, so I'm doing it again. Okay, now what I've done is, instead of removing the whole clamp, I just loosened one screw, this one, and remove the other one, so I can turn it around, and the mirror can just be pulled out, and then I can put it back the same way it was, so I don't lose anything in this process. Okay, the whole mirror is now out. And this side, which has this, one of the marks will go anyway. Doesn't matter. I'll have a mark here. which I left there. Yeah, that's good. That shows that mark will be here, and this clamp will be to the left of it. Another mark here, also tiny, and this is the bigger mark. This one is where this clamp will be. So this arrow, which I placed already, will be here. So let's go and do a cleaning. Okay, I've shown the full process in another video, it's a comprehensive video. So basically what I use is cotton wool, some washing up liquid, tap water, then I sprayed some isopropyl alcohol that we use for, it's called rubbing alcohol. You just spray it there. Again, gently with the rubbing alcohol, you move it around like that. And then when it is done, you just wash it again and rinse it with the deionized water so no lime scale marks will be left on the mirror. You can refer to my whole video about this, and this is the second time I'm washing this mirror, so it just works. Refer to that one, please, if you want to see the whole process. So the mirror is clean, just didn't take more than 10 minutes, so it's ready now. And I'm just rinsing it with the tap water, then after that I will use the deionized water. For removing the small droplets when I'm drying it, of course, I will use the tissue, just absorb the tip of the tissue, you bend it and make a sharp point by the tissue. Then drop by drop you absorb them to the tissue. That way it works really well. Then you can put it back in the mirror cell. Okay, the mirror is now left on this surface. Is an oven, and there is a hood with the light over it, so I can see what's happening here. I may try a little bit with the air blower, hair dryer, just to blow some of the water away. Whatever remains, I absorb it by the tissue. The mirror already looks really nice and shiny. The mirror now is completely clean, back to a good way it was. I just clean up the mirror cell and then install the mirror. I have now put the mirror back. I use gloves to lift it and put it here, and the arrow is almost there. I just shift it probably a few fractions of the millimeter, 1 millimeter, just to the left, and that will be done. Then I can clamp it again. So the mirror is now done, is installed. Slight blemish you see is nothing, it just I was transferring it. Anyway, the mirror is done. It's ready to put back in the telescope tube. I have to clean the telescope tube because there are a couple of. Just remember, tighten up the things, but not too tight, and do all little by little. So don't completely tighten up these two. Do this one also. Do this one, then gradually tighten up. Start again from this. So you don't want to introduce any stress to this mirror. Okay, now the mirror is back in the cell and ready to be used. I will just try to see if I see collimation. After that, just wait for the darkness. The sky is so clear I can see the M13 with the naked eye, and easily I directed a telescope at it. This is a 12-inch Skywatcher Skyliner 300p, and with the APM 20mm I can actually resolve the stars of this planetary nebula, this globular cluster M13. I can see individual stars to the core. I may go and just now put the 30mm Eyepiece just to see how it will look. This is unbelievable. I can see the individual stars of the M13 globular cluster. Every single one of them to the core can be seen. Never had such experience. Definitely not with the 8-inch Schmidt Cassegrain LX90. My question is it because I cleared the mirror today? I washed it, cleaned it completely. And now I can see the individual stars in M13. The main mirror, 12-inch mirror. The same thing, and bigger. This is Ethos 13mm, and this is the APM HTC 20mm. And I can see individual stars. Thousands of stars I can see in the globular cluster M13. Okay, I can say that the Nagler 31mm tape drive doesn't give the same good view as the APM 20mm. It's a bit wider angle, the stars are smaller, contrast is less, so I prefer the APM 20mm. And better than that, even Ethos 13mm. Contrast increases a lot. But individual stars in APM 20 and Ethos 13 is much more numerous. You can see them in the Nagler, but not as individual as a myriad of stars as what it is in APM 20. The image through the APM 20 is exceptional. Nagler, nothing close to it. I don't have the Teleview Ethos 21mm, but APM is better than the Nagler in this case. This is Skywatcher. It's only a 22mm. Is a gem. This telescope is a refractor f5 12-inch reflector, Dobsonian. I've observed with many eyepieces, including Nagler 31, with this instrument I'm talking about, APM 21mm 100 degrees, and Panaview 38mm, and Ethos 13mm. And I can say that this eyepiece actually seems corrects the coma aberration. The stars to the edge are completely circle, dots, no aberration, no deformation of the shapes of the stars. This is a gem of a telescope. I'm observing the M13 nebula, globular cluster. The stars of the globular cluster are visible. Fill the stars around it also are sharp, pinpoint to the edge. It's one of the best eyepieces. If you get one of these, don't sell it ever. Don't get rid of it ever. You never find anything as good as this. It's a magical magnification, 22 millimeter, 70 degrees, 2-inch eyepiece, barrel size. And he has provides a dark background, good contrast, at the same time well corrected image. The thing is that you don't see this eyepiece ever on sale as second hand. Anybody who got it, they don't sell it. This is a well kept secret. Now you may think Nagler or Teleview or something like that are really good. If you have not tested this one, you will not know what is a good eyepiece. And I bought it £50. New, £52. This is the best eyepiece ever. Look at the size of the lens. This is the telescope I'm using, this big light bucket. This diagram shows how different telescopes show the M13. Okay, this is the max vision. So with 12-inch, something like a 24 degrees is as good as the Skywatcher SW8 22 millimeter. I'm telling you, this is a good eyepiece. Tonight, of course, the viewing is not as good as the last night. Last night I could see thousands of stars right down to the core of the M13 globular cluster. Tonight I can see individual stars even at the core, but they're not as distinct and divided as what it was last night. Last night I could see the M13 with the naked eye, as bright as the nearby star, which is, I think, is Alpha Hercules, or whatever star is near it anyway, if it is not Alpha. And I could see it with naked eye, just pointed the telescope right at it. Tonight is not as visible as that. With the naked eye, no, it's not as good. Or you cannot see it with the naked eye. But with the telescope you can see it, and it's not as distinctive as last night. So it shows that seeing is important, even if you have a moderate instrument. Seeing is important. Oh, hallelujah! You can see the galaxy 6702, the one which is near the M13 globular cluster. I just followed this pattern. M13 is between two stars which form around, let me tell you, 120 degrees angle, or a corner like that, which the corner of the angle is the M13 and two stars are there. If you follow from first star to the M13, then you have to go at a 120 degrees angle toward the right, then same distance go upward. From there, continue a little bit to the right, you see two stars. Down that two stars is a fuzzy fainting fuzzy, and that is the NGC 6702. Oh, hallelujah. This is the finder chart for the constellation of Hercules, and this is also the finder chart for the M13. You can see the NGC 6207 at the top, the two stars in the lower and the left part of the cluster, you see. And the target is very easy in that 12-inch telescope. Of course, the eyepieces I was using were superb. They showed it also. Yeah, the thing is that, of course, I'm using the max vision 24mm 83 degrees. The thing is that M13 itself, globular cluster, is magnitude 4.5, so it's quite bright actually. NGC 6702 is magnitude 12 as far as I remember. So, really good. I can pick it up. I couldn't see it with the other eyepieces. I've not tested yet, so I've just may put other eyepieces and test to see if I can see with them also. Hallelujah. 22mm SWA Skywatcher, and NGC 6702 is actually better. And with direct vision, you can see you don't need averted vision anymore. Direct vision is there, and you can see it. And hallelujah, APM 20mm also shows it, and I can see some details actually in that galaxy NGC 6702. It starts to show some details, getting darker, of course, when you increase it with magnification, but the wider field of view also is very nice here in this case. So APM also stands out, direct vision visible. Okay, Panaview 38mm is very good for finding the M13 itself. You can see the NGC Galaxy NGC 6702 with it, but it's not good if you just want to find it for the first time. You have to use something a little bit with lower magnification, with higher magnification, something like 22, Skywatcher, SWA, or Max Vision 24, or APM 20. That will make it really easily visible. With this one, the faint objects get lost among all the details, and because it's tinier, you don't see the extension of this faint fuzzy galaxy. So I would go for a lower focal length, higher magnification, definitely better. Although this is good, it shows all the field of view from all those two stars and around the M13, and the two little ones which are near the NGC 6702. You can see all of that. And this is the image of the M13 which I took with a Huawei PT camera, plus camera, and an 8-inch Schmidt-Cassegrain telescope. It shows the red stars very clearly. These are the bigger images of the NGC, which hopefully shows NGC 6207. As you can see, it's a galaxy. I have a better image of that here, and you can see some hydrogen 2 regions in that image. Interestingly, Hubble Orbital Telescope also have taken some images of this. You can see them here. There's a relatively close, 30 billion light years galaxy from us. And thank you for watching. So I wanted to ask you that how you actually adjust this. You told me that you use a software to find the coordinates of a star. You bring that star into the center. You center it practically in your Dobsonian.
That's right, yeah.
Then you put your magnetic marker and you put it there. You already have added the base.
That's right, yeah.
Then you use a big Vixie, which is already leveled.
Yes.
And you put it there.
That's correct.
And then based on that level, you just actually go to that declination.
Yeah.
Or whatever it is.
Yeah.
Alt azimuth, altitude. You go.
Yes.
And then that's it. You're a sensor.
You are calibrated, and you can go anywhere in the sky using that software. So the next time you want to go to 20 degrees, move it around to 20 degrees.
Yeah.
And then if it's at 70 degrees altitude, put it at 70 degrees, look in here, and it will be there.
That's it. That's the beauty. Lovely.
Yeah, I don't know whether you ever go to Kelling. Do you ever go to Kelling Heath?
No.
That's astronomy.